We will start with the definition of a rational function. A rational function f can be described by f of x as p of x divided by q of x. Rational function is a ratio of two polynomial functions. But just like any other fraction, we can't have 0 in the denominator. We can't have 0 in the bottom of a fraction. So this bottom, q of x, should not be a zero polynomial. So when you are finding domain of a rational function, we find all x values for which this denominator polynomial is not equal to 0. So what happens around this value that makes the bottom of the fraction 0? We get something called a rational, vertical asymptote. And vertical asymptote, we're going to sketch them. It's a dotted line that helps us graph a rational function, okay? If your graph does any of these following around this line x equals a, we call this the vertical asymptote. So what does it do? Let's use some limit notation to review some limit notation to describe what the function is doing around this line. So, okay. As x approaches this vertical line a from the left, this function will just go straight up to positive infinity. Okay, so if I give you a picture of that, let me go ahead and sketch something. Say that this is a over here. Let me go ahead and draw a dotted line. Let's say that is a. Okay, you may have a graph that looks like this. So from the left, it is trying to get really close to this black dotted line, but what happened? Oh, let me zoom in and do that. So let's say from the left, it's trying to get really, really close to this vertical line, but as you get really close, whoosh, it's going to skyrocket up. If it does that around this vertical line, sometimes it's not graphed, but we should be able to kind of see this invisible dotted vertical line. If your graph does that around a vertical line, then we call that a vertical asymptote. It doesn't have to go up like that. It can also go down. Like for example, like from the left, it's approaching this line, but as you get really close to it, you're not allowed to close it. So you just you're not allowed to cross it, not close. You're not allowed to cross it, so you go straight down. So if I write that using interval notation, I'm sorry, not interval notation, limit notation, we can say something like limit as x approaches a from the left of f of x is equal to negative infinity. So from the left of this vertical line a, as x gets really close to this line, the line's going straight down. And we should talk about it from the right side too, right? X gets really close to this line A from the right, f of x can skyrocket up to positive infinity, or as x gets really close to this vertical line from the right, f of x can go straight down. So if the graph does any of these four followings, then we say it is a vertical asymptote. Okay? So not very often though, because our job is to graph a rational function. So we're gonna have to do that. But anytime you have a problem that's asking you to read a vertical asymptote, look for these special vertical line where the graph just goes crazy around it. Okay? They're gonna go either up or down. So how do you find these vertical asymptotes? It's so simple. You just have to find the zero of the denominator that is not the zero of the numerator. The second part could be confusing, but in an easier example, in a straightforward examples, all you need to do is set the denominator equal to 0. So determine the vertical asymptote. You set the denominator equal to 0 and solve for x. X equals 7 is the vertical asymptote. So in this one, set the denominator equal to 0. x squared minus 144 equals 0. You guys can solve this either factoring or taking square root. I can add 144 to both sides. I can take square root of both sides. But when I take square root, you agree we have to draw or put plus or minus sign. And square root of 144 is 12. So this graph, the graph of this function will have two vertical asymptotes. I'll show you real quick, okay? I'll show you the graph of this. Let me open up a graphing calculator real quick. If I graph this function, 12x divided by x squared minus 144, and zoom out. Notice that they don't graph asymptotes, but I know what they are, so I'm going to go ahead and graph them using dotted lines. Take a look. I'm going to put an orange dotted line and another orange dotted line. And you see what the graph, I'll make the graph a little bit darker. You see what the graph is doing around these orange dotted lines. To the right, from the left is approaching, is going straight down. From the right side of negative 11, as it gets really close to this orange line, from the right is going up. See, that is what the graph will do around vertical asymptotes. Graph will never cross its vertical asymptotes. So that's what they look like, and that is how you can find them. Rational functions can have one, two, or more vertical asymptotes, and this one had two vertical asymptotes. So these two are very simple, but I'm going to show you another one that's a little bit tricky. H of x, this one. A lot of people find two vertical asymptotes for this case, but it actually only has one. I'll show you why. So if I factor the denominator, the numerator is x plus 4, and the denominator is going to be 5 times 4 is 20. 5 plus 4 is 9, so it's got to be positive 4 and positive 5. Very often, listen, a lot of times people say that the vertical asymptotes are at x equals negative 5 and x equals negative 4. But negative 4 is not a vertical asymptote. Only x equals negative 5 is the vertical asymptote. And let me show you why, okay? What happened is that x plus 4 cancels out. If it does that, it's not a vertical asymptote. We actually call x equals negative 4 a hole. So if it cancels out, it has a hole, not a vertical asymptote. So this graph only has a vertical asymptote at x equals negative 1. We didn't have to worry about that case because nothing really canceled out on the first two f and g, but I'll show you a picture of this. So the function is x plus 4 on top of the fraction. And the bottom of the fraction, we have x squared plus 9x plus 20. We said that the vertical asymptote is at x equals negative 5. Okay, and take a look at this graph. We really only have one vertical asymptote right here. So what's happening at x equals negative 4? Take a look. I'm going to go ahead and go to negative 4. See? At this point right here at negative 4. Ta-da! Take a look. It's an open circle. We have negative 4, undefined. So when we graph a rational function that has a hole, we're going to have to plot an open circle. Okay? But that is not a vertical asymptote. If it cancels out, then it becomes a hole, not a vertical asymptote. So I think that's enough for the first page. I'll come back and show you how to find horizontal asymptotes in my second video.